In this video, we will identify the x and y intercepts from an equation, graph, and a table of values of a linear function. The x-intercept is going to be the point where a function passes through the x-axis. So on a graph, it's really easy to find the x-intercept when it crosses the x-axis at a perfect point. So here we have an x-intercept of -1, 0. That's where this linear function crosses the x-axis. Notice in the point that the y value is 0. Anywhere on the x-axis, the y value is going to be 0. This important fact is going to help us when we are trying to find the x-intercept from an equation. If the x-intercept will always have a y value of 0, to evaluate it from an equation, we can substitute 0 for the y value. So plugging in 0 for the y, we'll get this equation that we can then solve for the x value of the x-intercept. So after solving for the x-intercept here, we get an x value of 6. The x-intercept is then written as the point 6, 0. Notice again the y value is 0. In a table of values, we look for where that y value is 0. So the y value is 0 here. So this is our x-intercept. These three examples I want you to do on your own from this graph, equation, and table. Now we're going to talk about the y-intercept. The y-intercept is where the function passes through the y-axis. So here we see the point 0, 3 is the point where it crosses the y-axis. Notice in the point that the x value is 0 for the y-intercept. So that's how we're going to solve it from an equation. We're going to substitute 0 in for the x value this time, because anywhere on the y-axis, the x value is 0. So plugging in for 0 on the x, we'll get -2y is 30, so y is 15. So the y-intercept is the point 0, 15. Notice again the 0 is on the x value. Notice here in our table again that where our x is 0 is our y-intercept. So our y-intercept is 0, 0 here. I want you guys to do these examples at the bottom.